Today we would like to share how to distinguish nystagmus from square wave jerks and noise on VOG graphs. Nystagmus is sawtooth shaped, with a quick phase and a slow phase. By contrast, square wave jerks, as their name suggests, show couples of square-shaped waves in VOG. Both patterns usually come in groups, with multiple similar waves appearing repetitively. However, nystagmus indicates dysfunction of the vestibular system, whereas square wave jerks often occur in healthy people. If the software's analytic system shows a nystagmus greater than 10 degrees per second, but the VOG graphs at that time show irregular waves or silence, it is considered noise and should be excluded. Now we will show a few cases. In this first case, the horizontal trace shows typical nystagmus with quick phases to the left. The vertical trace is almost silent, with only a few blink artifacts. In this case, the horizontal trace shows a persistent nystagmus, including a few blink artifacts in both traces, shown by the arrows. This example is not nystagmus. These are square wave jerks. Though they can be large and frequent in patients with cerebellar disease, most happen in normal individuals. So we do not designate square wave jerks as abnormal eye movements unless their frequencies exceed 2 Hz or their amplitudes are greater than 5 degrees per second. In this picture, the horizontal slow phase velocity at the time point of the black bar is over 10 degrees per second, labeled as 11.5 degrees per second. This seems to be eligible for randomization. However, please take a look at the VOG traces. The horizontal trace near the black bar does not show any sawtooth waves. The computer may mistakenly identify some slow, normal eye movements as slow phases of nystagmus, so please be careful. This is noise and should be excluded. Another example. Horizontal slow phase velocity at the time point of the black bar is labeled as 24.6 degrees per second. It's pretty high. Would you randomize this patient? Clearly, the horizontal line between 9 and 12 seconds reveals nystagmus. But there is no definite nystagmus on the red line at the time point of the black bar, even though we can appreciate a weak nystagmus on the vertical trace. So we cannot say there is nystagmus as high as 24.6 degrees per second, and in this case, we would not judge the patient to have nystagmus slow phases over 10 degrees per second. How can we address this difficulty where the time point selected may not represent nystagmus? Moving the time point of the black bar to the sawtooth waves of 9 to 12 seconds, we pick the point where the slow phase velocity is 17.4 degrees per second. Here are slow phases of nystagmus greater than 10 degrees per second, so the patient is still eligible for randomization.